Hi, I'm Indumati. My project title is Resource Depletion Attack Avoidance on Packet Forwarding in Adhoc Network using SAODV. I'm doing my project in VelTech Multi-Tech Engineering College. The main objective of my project is reduces the energy usages in the packet forwarding by avoiding the vampire attack. When transferring a packet from source to destination in the wireless network, there are possibilities for occurring the attackers. The one type of attack is the vampire attack, that is I am going to discuss in my project. The resource depletion attack at the routing protocol, which permanently disables the network by quickly reducing the node's battery power. This type of attack is called the vampire attack, and the vampire attack are not specific to any specific protocol, but it can easily affect the many popular classes of routing protocol. A single vampire attack can increases the network's energy usages. So, methods to detect and securing data packets from vampire attacks are discussed. In the existing system, the widely adopted countermeasures to avoid the vampire attack is the PLGP routing protocol. All the existing attacks are the packet drop attack, but the vampire attack can affect the general properties of routing protocol. In the PLGP routing protocol, it consists of a topology constructing phase followed by the packet forwarding. During the forwarding phases, all decisions are made independently by each node. So, it increases the energy usages. In the vampire attack, there are two types of attack, that is corrosion attack and stretch attack. The most common serious problem of vampire attacks are stretch attack and corrosion attack. In the stretch attack, it increases the routing loops between each node, and it causes the extra energy usages for packet forwarding. And that figure shows the honest node is node E2 sync, but the malicious node introduces the loops between each node, and it increases the energy usages for packet forwarding between source to destination. And the stretch attack is, it increases the packet path length for transferring a packet from source to destination. So this also increases the network's energy usages. While using the PLGP mechanism, it is I already told it is a packet forwarding phase. Due to that, there are several limitations of networks, that is code word and certificate identity can be easily duplicated, and also excess energy, and the bandwidth is also used at the topology construction phase. Due to environmental problems, loss in the information, due to that the security level is low. And the overall block diagram for my proposed system is, and the system monitor is used to monitor the packet transmission between source to destination. In the above part shows the corrosion attack, that is how the corrosion attacks are entered in the networks, and the below part shows the stretch attack methods. So observe the security measures to prevent the vampire attacks are those used to protect routing infrastructure. In this paper, I showed the Adhoc on-demand distance vector routing protocol can be modified to probably avoid the vampire attacks during packet forwarding phases. Even though the existing AODV is designed to overcome the routing loop problems, but still it is not a feasible method for efficient packet transmission, which utilizes more battery power. So the modified technique is SAODV routing protocol, that is Secure Adhoc On-Demand Distance Vector Routing Protocol. And also I'm going to use the energy vector monitoring algorithm. This is used to avoid the extra energy usages in the network. For using the SAODV routing protocol, we can overcome the limitations present in the PLGP routing protocol. that is data packets are secured from the vampire attack, and the limited energy is used for packet transmission, and also security level is increased when using the SAODV routing protocol. The modules involved in my project is base file creation, data transmission, key extraction for node identification, topology discover and maintenance phase, and identifying attacks by securing data forwarding. And the hardware requirement is PC, and the software requirement is front-end tool is NST, and operating system is Fedora. In the first module, that is base file creation and the data transfer, just to trace the neighboring sensors node. Before that, creating the many sensors node for transferring your packets. To resolve the collisions by using RTS and CTS mechanism, that is request to send and clear to send. Then to transfer the packets from source to destination. And then to transfer packets to each neighbor node, and finally shows the result analysis of energy drain nodes. And the key extraction for node identification module. In this module, generating the cryptographic key for each node. For generating the key, RSA algorithm is used, and send the key details to every constructing nodes. For every key sending node, trace the neighbors using the local broadcast scheme. And after that, code word and key verification is done in between every node while establishing a link between them. Thus, the external vampire node or malicious node can be eliminated from the network. After that, the link will be established between each node. That is the honest node. In the topology discover and maintenance phase, generating the route request and route reply format for every packet sending. And the first diagram is the route request format, and the second is the route reply format. The source node broadcasts a route request packet to all of its neighbors within the communication range. After receive the route request in the destination, it sends back the route reply packet to the node from which it got the first route request packet. That is which is send the route request packet to the nodes, surrounding nodes. After getting the route reply packet, the source node transmits the data packet for the honest node. In the identifying attacks by securing data forwarding module, here can be identified which type of attack is present, that is the carousel attack or stash attack. As I already told what is the carousel attack, just introduce the routing loops between the same packet and repeatedly travel the same set of nodes. And the carousel attack can be eliminated by checking the index number that is stored on the packet header and the index number to be stored in the local routing table of the node. And the stash attack is that it increases the packet length in the network. It can be eliminated by independently checking on the packet progress. And as I already told, energy weighted monitoring algorithm is used to avoid the extra energy usages in the network. In the energy weighted monitoring algorithm are two phases, that is network configuring phase and communication phase. In the network configuring phase, the main aim is to establish the optimal routing path. For that, sending the energy weighted packet to all of its surrounding nodes. After the surrounding nodes get the energy weighted packet, node replies by sending the energy reply packet to the each node, and it also updated the current energy level. Using the current energy level, it can be chosen the least distance path for transferring the packets between source to destination. After chosen the least distance path, and through the least distance path, the packets are transferred to the packets are reaches destination. In the communication phase, the main aim is to avoid the same data packets transmitting. It can be done by repeating packets is eliminated by aggregating the data transmitting. The aggregating is done by copying and comparing the data packets which is transmitted. After comparing the data packets, if the already packet is present, it can be eliminated, and original data packet can be transmitted to the destination. These are the snapshot of the simulation result. That is first generating the many sensors node. After identifying the node, it is an attacker. When the attacker is present, it introduces the malicious path for transmitting a packets. And overcoming the attacks, it is the honest path for transferring the packets between source to destination. Here source node is 0 and destination is 9, and the node 8 is an attacker node. And this is the snapshot for stretch attack. First, normally transferring a packet from source to destination and created many sensor using many sensor nodes. This shows the malicious part, that is clearly shows it increases the more number of packets nodes in the network. And here also identifying node 8 is an attacker node. After identifying the attacker node,